All right, let's talk some physics in terms of power output. So you're going to try and solve the power of a rocket today. Ooh, exciting. So here's your scenario. You got a rocket being used to launch a 500 kilogram satellite into Earth orbit. It takes the rocket 8.5 minutes to reach a speed of 8,000 meters per second. That's fast. And an altitude of 500 kilometers above the surface of the Earth. Your goal is to determine the power output of the rocket to get the satellite into orbit. Now, to simplify things, we're going to assume this rocket has no mass and does not use up any actual fuel, because that would make this problem a lot harder. Okay, so we're going to suspend some reality just so we can do some more basic physics here. All right, so your job is to figure out that power output of the rocket during its launch, and we'll see if you got the right answer, okay? So work on that, pause the video, and come back in a few seconds, and I'll give you the answer. All right, so there's your answer right over here of 3.617 times 10 to the 7th watts. It's huge, massive. Although it is a giant rocket, so it makes sense. All right, so if you got that, awesome. If you didn't, let's walk through how we get there. So first things, I'm sure that you drew a nice little picture of the situation so you could translate it a bit better. So that's what I have hidden behind door number 1 here. So here's my scenario. There's my rocket. Look at that rocket. It's like a box. Oh yeah, that's right. It's just a box. So now I'm going to be using energy transformations to solve this because it's power, and power is defined as the rate at which energy is transferred, aka work is done. So before scenario, it's on the ground doing nothing. Afterwards scenario, it's up in the air going 8,000 meters per second, and it's 500 kilometers above the ground. I need to choose my zero line, so I'll call this to be Eg equals 0, the very ground itself. And then, based on that, I got to do an LL diagram. So hopefully it did that. So here's my LL diagram. See if it looks like what you did. LL diagram. Behind door number 2. Boom, LOL. So it starts on the ground, it has absolutely nothing. At the end, it's both moving, so it has kinetic, and it has height, so it's got gravitational. So how do you go from nothing to having something? Well, you got to put work into the system. So this is the energy that the rocket itself transferred to the satellite. So that's how much work was put into the satellite, thus my system. So this is my LOL. So I have work equals EK plus EG. So now it's a matter of replacing these with the equations and then kind of seeing where I can go with that. So give that a shot while I reveal door number 3. So if you replace all that stuff, you are left with this. Work equals 1/2 mv squared plus mgh. You know the mass, you know the speed. Don't forget to square it. You know g is 9.8. The height is 500,000. Do not just put 500 because this was given to you in kilometers. So you gotta make that change because kilo means 1,000, so it says 500,000 meters. So that's where we get our 500,000 for. When you do your math, you get 1.8475 times 10 to the 10th joules. So that's how much work was done. So now you got to do that secondary equation because power equals work divided by time. So now we can solve for that. So if we do know the time, it was given to us as 8.5 minutes. Now if you look at that time, it's in minutes. Those are not our base units. So you have to convert that into how many seconds, which if you multiply that by 60, because there's 60 seconds in a minute, you do not get 50, you get 510. So this is 510 seconds, and that's what we're going to be using in our math. So power equals work divided by time. We knew our work from over here. All right, we just take this value and it goes up in there. And then that's our time from down there. And crunch your numbers, do your math, and therefore you get the power output of that rocket during this time. All right, so hopefully you got it right. Hopefully if you didn't, you found the error of your ways and you can do it next time. All right, so until next time, this is your teacher saying bye-bye.